the International Maritime Organization and the 1974 SOLAS Convention established the ultimate authority over global maritime safety. The core operational mechanism of the convention is found in Article 8. It establishes a protocol called tacit acceptance, which allows the code to bypass slow national ratification processes and rapidly update its own regulations. Through this tacit acceptance mechanism, SOLAS has implemented over 56 distinct amendments since 1974, functioning as a continuously evolving legal framework. A stark contrast exists between the bureaucratic reality of London boardrooms and the violently corrosive physical environment where commercial ships actually operate. This creates a central paradox. A static legal text must effectively govern the millimeter-level structural integrity of a 300-meter steel asset navigating extreme weather conditions. SOLAS resolves this by operating as a dynamic engineering engine, where international mandates literally bend and shape the steel of the global fleet. Looking at the vast scale of this tanker, Chapter 2.1 of SOLAS serves as the direct mandate for its physical geometry, dictating the structural subdivision, stability requirements, and construction standards of the hull. Chapter 1 then acts as the administrative enforcer, dictating a strict temporal matrix of continuous surveys and inspections. True seaworthiness exists exclusively at the intersection of the engineering mandates of Chapter 2.1 and the life cycle oversight of Chapter 1. We will deconstruct how SOLAS dictates a ship's design for a 25-year lifespan and forces owners to prove its integrity through rigorous documentation. Compliance is a continuous physical state. A vessel is only as compliant as its last survey and its current geometric reality. Before a ship can be legally surveyed, its geometry must be rigidly codified. This 3D wireframe illustrates the definitions laid out in Chapter 2.1, Regulation 2. The subdivision length is the greatest projected molded length at or below the decks that limit vertical flooding. This length is capped by the forward and aft terminals, establishing the strict longitudinal boundaries of the vessel. The deepest subdivision draft, highlighted here, corresponds to the summer load line. This serves as the critical baseline for calculating intact and damaged stability. The bulkhead deck is the uppermost deck to which transverse watertight bulkheads are carried. Its function is to contain catastrophic flooding within specific vertical parameters. Regulation 2.15 defines machinery spaces as strictly isolated zones containing main propulsion. They are specifically designed to contain mechanical failures and prevent fire from spreading. The term watertight is a legal definition requiring scantlings capable of preventing water passage in any direction under specific heads of pressure. These precise geometric definitions transform a complex physical asset into a standardized, calculable, and legally enforceable model. Regulation 310 introduces goal-based ship construction standards, representing a shift from rigid checkbox rules to comprehensive life cycle engineering. Ships must now be explicitly designed for a specified design life, ensuring structural integrity and environmentally safe recycling for a period typically spanning 25 years. Regulations 3.2 and 3.11 establish strict performance standards for protective coatings in dedicated seawater ballast tanks and crude oil tanks. These coatings must be applied during initial construction. Their purpose is to prevent mid-life structural failure caused by invisible internal corrosion. Regulation 3-6 governs the physical accessibility of the vessel, requiring safe access to and within cargo areas and ballast tanks. It is illegal to build an enclosed space on a commercial vessel without designing a permanent, safe route for future human surveyors to enter it. The exact geometric requirement dictates that vertical openings and hatches must have a minimum clear opening of 600 by 600 millimeters to allow a surveyor wearing a self-contained breathing apparatus to enter. These access routes must be documented in a mandatory ship structure access manual, approved by the administration and kept permanently on board. Chapter 2-1 forces architects to build ships that facilitate and survive their own future inspections. Once the geometry is set, the physical engineering requires strict administrative oversight to maintain the right to sail. Chapter 1, Regulations 7-10, lay out the harmonized system of survey and certification. This timeline visualizes the baseline 5-year compliance cycle required to maintain a cargo ship safety construction certificate. The initial survey occurs before the ship is put into service, It verifies that all structures and machinery perfectly match the blueprints approved under Chapter 2.1. Annual surveys are required within 3 months of the certificate's anniversary date to ensure the ongoing maintenance of all required equipment. Between months 21 and 39, an intermediate survey replaces one annual survey, requiring a more intense inspection of the steering gear, boilers, and electrical installations. The 5-year cycle culminates in the renewal survey, a massive, comprehensive inspection that renews the vessel's legal status for another half-decade. Regulation 10.A.V introduces mandatory outside bottom inspections. At least 2 are required every 5 years, spaced no more than 36 months apart. This specific requirement forces operators to regularly pull massive steel assets entirely out of the water for close-up structural review. Between these scheduled nodes, Regulation 11 requires the maintenance of conditions. If an accident occurs or a defect is discovered that affects the safety of the ship, the master must report it immediately, which can trigger an unscheduled survey. The surveyor on the ground operates as the ultimate arbiter, verifying that the physical condition of the steel matches the particulars of the certificate. The HSSC matrix weaponizes time. It forces the physical ship to continuously prove its geometric design intent to global authorities. The physical engineering requirements of Chapter 2.1 and the temporal matrix of Chapter I operate as a single interdependent system. By applying the 5-year survey timeline directly onto the ship's 3D geometry, the interaction becomes clear. The goal-based standards ensure the ship can be inspected, while the survey matrix ensures it will be inspected. As marine technology evolves, the expanded Maritime Safety Committee will use Article 8 to tacitly adapt the code to match new physical realities. This produces a continuous, unrelenting cycle in the world of global shipping operations: design, build, inspect, adapt, and repeat. A commercial vessel is constructed out of its legal and documentary history as much as it is built from steel. Without a valid cargo ship safety construction certificate and an up-to-date ship structure access manual, the physical asset is legally paralyzed and unable to trade. In the eyes of international maritime law, true seaworthiness is the flawless, ongoing execution of both physical geometry and temporal inspection.